This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Like made an introduction the other time, we want to derive the sinusoidal transverse wave equation. And like I said, we should have the background of what wave is all about. If you, we can think about dropping a stone into a still water surface. Let's say this is a water surface that has not been disturbed initially. Now, if we drop a stone into this water surface, you can see that the water level will be moving up and down in this format, as you can see. Now, the particle in the water, when the water was still, all lies uniformly on the surface, on this straight line along the x-axis. But when the stone is dropped, the water levels keep shifting, and then the particle shift to the maximum here at this point, and then to the minimum here at this point, then back to the maximum at this point, and minimum at that point. This kind of movement is said to be periodic, and then this particular shape of the graph that we have here resemble that of a sine graph. Now, if you look at this particular diagram, the maximum or the minimum displacement of the particle, this part of the maximum displacement of the particle, this particular point of displacement is known as the crest. So C is the crest, it's called the crest. And the point of minimum displacement downward here, which is T, is called the trough. It's called the trough. So if you look at this diagram, we can see that for one full cycle of the wave, from here to here looks like a half cycle diagram, and from here to here looks like another cycle diagram. If you look at these two half cycle diagrams, we have what is called a full cycle wave, and the distance between the starting point and the finishing point of this full cycle is called the wavelength. So we normally use this symbol to represent the wavelength. So the wavelength is the horizontal distance travel during the full traveling of the wave, the horizontal distance travel through the full cycle of the wave. Through this particular full cycle of the wave, the horizontal distance travel is called the wavelength. Now, another way to measure the wavelength is to look at the maximum point of displacement of the particle of the medium at one point, and the immediate maximum displacement of the particle, the neighboring maximum displacement of the particle. If you look at the distance between them, it's also equivalent to the wavelength. Or if you look at the minimum displacement of the particle of the medium to the neighboring minimum displacement of the particle of the medium, the distance between them is known as the wavelength. Now, like I said, there is a horizontal displacement of the particle, there is a vertical displacement of the particle of the medium as the wave is moving perpendicularly. Now, along the y-axis here, that is the direction of traveling of the particle of the medium, and the horizontal is the direction of traveling of the wave. Now, this particular vertical displacement, we want to relate it to this horizontal traveling of the wave. Now, we have a function y. This particular displacement is a function of the horizontal displacement x and the time. So it's like a displacement time function. And because this particular wave we are referring to here take that of the sine graph, and the equation of a sine wave is given as the amplitude of that wave. That's the maximum displacement of that particular graph, which is this a. If you look at this maximum displacement, you trace it to this place, that's the amplitude. So it's given as the amplitude sine theta. We are talking about this theta because this graph resembles that of the sine graph. Now, I want to reconvert this theta to reflect horizontal displacement and the time. This is how we are going to do it. We want to discuss about the angle and distances. For the angle theta in radian, this particular theta in a full cycle is 2 pi. For a full cycle is 2 pi, and any distance x for a full cycle of the wave is the wavelength. So we can relate this particular ratio to each other. So in order to eliminate this theta in this particular expression we have here, we can make theta subject to the formula by cross multiplying 2 pi to that side. So in this case, our theta now is equal to 2 pi x divided by the wavelength, or lambda. So we can go back to this particular expression we have here and replace this theta in radian with 2 pi x divided by the wavelength. So in a nutshell, this vertical displacement of the wave, which is a function of the horizontal displacement and time, can now be written as the amplitude times sine of 2 pi x divided by lambda. Now, if the wave is traveling along the positive x-axis, it will travel. We know that velocity is displacement x divided by time. So x will not be velocity times time is equal to x. So if there is any displacement towards the positive side on this particular traveling of this wave, we can relate this shifting of the wave to this new position in the positive x direction as amplitude sine 2 pi divided by lambda. So because of a shift in the wave, there is a difference between this position and this new position vt. So I will write this x now as x minus vt. Now the expression that I have here has a name, and it is called wave number. It is called wave number. Wave number simply give us the idea of how many cycles of the wave has actually passed during the propagation of the transverse wave. So this particular wave number is represented with letter k. So the wavelength letter k is given as 2 pi divided by lambda. So now we can open this bracket and have our vertical displacement of the wave, which is a function of horizontal distance displacement along the x-axis with respect to the time, as amplitude sine. So 2 pi over lambda times s will give us 2 pi x divided by lambda. Then 2 pi over lambda times vt will give us minus 2 pi over lambda vt. So this particular expression that we have here is called the wave equation. In my subsequent video, I will now present a simple exercise using this transverse wave equation to find the what is called the period t of the wave. Period is the time taken for the wave to complete a full cycle, and the frequency also of the wave is the number of cycles that the wave completed per second. Is called frequency, and then this number of cycles per second in standard units is called the hertz. So, and the period is measured in seconds. So this particular expression, we can also use it to find the speed or the velocity of the wave. This expression also reflects the amplitude. So A in that expression is the amplitude. And we should remember that the relationship between the period and the frequency is given as frequency is equal to 1 all over period, or period is equal to 1 over frequency. or if you multiply the two of them together, frequency times period will always give us 1. Take note of that. Thank you for your patience in listening to my presentation here. This is Orekoya Olusegun Physics Mathematics Fundamental on YouTube. Please do not forget to share, like, subscribe. Also, click on the notification button to have more of my video. And also, please look up to my next video in how to use this wave equation that I have derived in getting all the parameters that I've listed here. Before I move further, I want to also let us recall that the angular velocity of a wave is given as theta in radian divided by time. And for a full cycle of the wave, this theta becomes 2 pi, and this time becomes the period of that wave. And this expression that we have here, because 1 over t is period, so this particular angular velocity can also be written as 2 pi f. Because this angular velocity is also having frequency in its expression, it is also known as the angular frequency. Have a nice day. Bye. Thank you.